board, please. So if I filled in that first blank with, let's say, Seattle. I've been to Seattle 3 times in my life, and every time I went, it was raining. I think it always rains, and I put Seattle in there again. Would we agree with that? That it always rains in Seattle? How do you know that? What? Some days it's sunny. And how do you know that? Everywhere? Okay. What if I told you you had this experience right here before you were 5 years old? So I'm saying you went out to Grandpa and Grandma's house. They lived in Seattle or Portland or something. And every time you went there, it rained. And you know how it can rain sometimes in that region for days at a time. So every time Jasmine went out there, it rained. Would she maybe think that this is true? As a little kid? You know? So we're going to do a lot of this here in this chapter. Actually thinking. Oh my God, right? Now, here's the other thing. When you start doing this chapter and the next chapter, if you struggle, how many people have a little brother or sister at home? How many people have maybe a grandpa and grandma they could see a lot of? So what I'm telling you is this. If you struggle, go and ask the smallest kid that you can what the answer is. Swear to God. Okay? Or ask the oldest person that you can. And I'm saying older than me. Saying grandpa and grandmas. Why? Because they see everything as black and white. Right? A little kid will just say, hey, I can tell that. And they won't have to think about it. They'll just give you an answer. So I know it sounds weird, but if you got a 5-year-old brother and sister or cousin that you can ask them and they'll answer the question for you. And probably 90% of the time they'll be right. I know, it's frustrating. Okay? So that's even better than Keaton's 89% he's getting right now. So what we're going to start off talking about today is something called inductive reasoning. So that's what section 1 is all about. Any idea what this means? Besides looking up on the board and reading it? Have you ever heard of this before? Probably not, right? So inductive reasonings just simply means that you came up with it using specific number of examples. So maybe you're taking a survey. Maybe you go out and you sit in the bench in front of school here. And you start taking a bunch of examples or just observations. And this leads to a prediction. So for you sitting there as everyone's coming to school, you can make some kind of generalization. So for instance, you're sitting on the one of the benches and everybody comes and they're not in dress code. What conclusion would you make? Well, there would probably be several that you could, right? It's a Honduras day. It's a CLT day. It's homecoming. Those would all be relative good examples of trying to come up with something, right? So we're going to try to find examples that lead us to say something about whatever we're trying to develop. When we do this, this is going to lack logic sometimes. Logic's what we're going to talk about all day tomorrow. What's logic? Logic is street smarts in a sense, right? How many of you aren't book smart, but you could survive on the streets? That's logic. Okay?
You could not.
Right. So, from here then, as we do this, this is going to lead us to develop conjectures. Anybody ever heard this word? So remember when I told you that we would have certain things that we're going to look at from here on out? That includes vocabulary. So a lot of us struggle just in basic mathematical vocabulary. So as a professional development, I don't know, 3-4 years ago, one of the big things that we talked about was vocabulary in subject base. And we came to the conclusion, especially in math, that a lot of people struggle in math because they don't understand the vocabulary. So I want you to go through this sheet before we continue on here and circle here how much you understand or would understand these words. If you've never heard of them, you would circle number 1. If you've seen it or heard it, just in passing, it's a 2. You definitely know this term is a 3. And number 4 is you can actually explain the term. So again, a lot of this, in this particular case, you're going to probably have a lot of 1s. Because you might not have heard of a lot of these things. And that's okay. Geometry is totally a new way of thinking, honestly. As we go through the rest of this chapter, I want you to keep this sheet every single day. And if we get to one of those words on the sheet, and you definitely have it as a 1, then I want you to turn it over on the back side and write the definition of what it is. Okay? Then if you said that you had a 4 as one of those words, just make sure that your realization or knowledge of the word and how you would explain it corresponds to what we would actually say. Okay? So the first one is a conjecture. Anybody have a 3 or a 4? You know what that means? Perfect. So we're all going to learn something today. So what's a conjecture? Any idea? What if I told you another word for a conjecture is this? A conjecture is basically a hypothesis, which in science is an educated guess. So for some of us, this is going to be easy because we are educated and we use our mind. For some of us, this still could be a stretch. So again, we're going to make this educated guess by sitting out there and looking at examples. So my educated guess why everybody was out of dress code was that it was a CLT day. We're trying to make money for CLT. Then I would come in and I would try to figure out so when we make these conjectures or educated guesses, they can be true or false. Right? Was I right by the educated guess that I made? Was it a CLT day? Was it homecoming? Was it whatever? So when we're talking about true or false, conjectures can be either. You only need one false, one example to make it false. I don't even have to have this example be the reason why. So meaning, if I was doing my experiment out in front of the school and I said that it was a CLT day, and Hannah says, no, I think it's homecoming, could her reasoning be correct? It could be, right? So if it's a chance of that's one false statement, or me finding an example that proved my educated guess false. So then the whole thing's false. And what Hannah would have came up with then is, after a false statement, we come up with a counter example. Is this another word on our list? Okay. So what's a counter example? Bless you. Maybe you don't know exactly what a counter example is, but what would you think it is? By kind of the word, or piecing the word together. Well, a counter example is what? Yes. Just another idea. Or a possibility of another true statement. Exactly right. So basically, we're going to look at all these things and we're going to try to come up with, are they true or false? And all I have to do is come up with one thing that would prove it different. Okay? So, look up here at the board, please. So the first one says, when you open a door, the angle the door makes with the door frame is complementary to the angle the door makes with the wall. So first off, do you understand what it's saying? If I come over here to this door, here's my wall, right? Or I can think about the wall on the other side. When I open this door, is this angle, if this is my wall, even though it's my doorway, and this angle, is it complementary? Well, first off, I have to remember what complementary means, right? What's that mean? 90 degrees. So, would you say, if I'm including this wall and this angle over here, would it always be 90 degrees? No, because why? What could I do with my door? I can slide it even farther open, right? So, that's my counter example. My counter example is me pushing the door farther open. And because I can come up with the counter example, one false statement makes the whole thing a false statement. Okay? Make sense? Now, could it be true? Yeah, it could be true. The first part of it could have been true. But when I can come up with something else that makes it false, then it's false. All right, so again, I'm writing a conjecture. Here's my next one. Lines K and M are perpendicular. Write a conjecture and draw a figure. So a big part of this, when you're talking about counterexamples, you can always draw a picture to use as your counterexample. So you might not be able to really explain it in words, but maybe you could draw some kind of figure, and that figure would count. All right, so if lines K and M are perpendicular, the first sentence you cannot argue. If they write something, you cannot argue it. So what's your conjecture from that first sentence? What would you say? Well, they already said they're perpendicular. But what do I know if they're perpendicular? They intersect. Exactly right. So I would say my conjecture is lines K and M intersect. What else could I say about it? If I know they're perpendicular, they make a 90-degree angle. That's another conjecture, right? And how could I do that? To prove it, I could actually draw a set of perpendicular lines, right? And how do I show everybody that they're definitely perpendicular? I put my box, right? And then I would come back and I'd put K up here and M down here, and I proved my hypothesis, right? So when they say that they are perpendicular, can I draw something that wouldn't? Not really in this case, right? So my conjecture here would have been true. Okay? I don't really like the next example. This is a good one. Someone makes toast for breakfast. Somebody got up and actually made toast. After a few minutes, the bread pops up, but then it isn't toasted. What's your conjecture?
Toaster wasn't plugged in.
It wasn't plugged in. What else?
It broke.
It broke.
Power outage.
They didn't leave it in long enough. Power outage. All of these are reasons why, right? Can you argue any of them? The only way Kenzie would know that Cameron's toaster didn't work is if she went over and checked out why Cameron didn't get toast. Bless you. Right? So, how about the next one? Given points A, B, and C are collinear. What's that mean again? They're on the same line. And B is between A and C. So, bless you again. Can you, one, either visualize this or draw this? Okay? Sam made the conjecture that B is the midpoint of AC. Is his conjecture true or false?
False.
All right.
Because it could be between it anywhere. It doesn't have to be right on the midpoint.
Exactly right. Everybody agree with that? Okay. So what if Ryan said, well, I think I'm going to draw it and put B on the outside. He can't just put the B on the outside of A or C because they specifically told you that B is between A and C. So you can't totally rearrange the initial problem. You have to take what they give you as the given as its truth. But then from that given, can we prove him false like Cameron just did? That make sense? All right. So the given is an important part of this. And we'll talk a lot about givens. So, given. FG is, what's that symbol again? Congruent to GH. What's that mean? They're the same thing, right? Okay? Conjecture. G is the midpoint of FH. So first off, does that make sense what they just said? So if G is the midpoint of FH, could I have something where FG and GH are still congruent, but G wouldn't necessarily have to be the midpoint? Can you come up with something where G would not be the midpoint, but I could still have FG and GH be congruent? Anybody? Remember, we only need one thing for it to be proved false. So can somebody come up with this segment right here being congruent to this segment right here without G being a midpoint? So everybody says that's true. I don't know. Okay? So again, then we come back to counterexamples. We're going to come back and do some more examples of this. But counterexamples. Just another idea, if you want to also write, could be a number or a drawing. Or simply a statement. To make a conjecture false.
You have to tell why it's true.
Yes, if you can say why it's true, go ahead and say why it's true. If not, that's okay. So the other way that we're going to just do here is look at a bunch of things where we can come up with a hypothesis. So that's the first main part of this, is to actually come up with something that makes sense. So can I make a conjecture that describes the pattern that's shown? And if so, can I find the next item? What are we doing to everything here in this pattern? Multiplying by?
2, 3, 4, 5.
So we're going up in order, right? The first one was 2 times 2, 4 times 3, 12 times 4. So what's the next one? 240 times what? 6. And what do we get? Go ahead and do the math. 1,440. So apparently we'd all have to get our calculator out to do the math. No problem. Next one. Write a conjecture that describes the pattern shown. Then try to find the next item. So what do you think? Multiply by 3? If I take the first one and multiply it by 3, I get 9. But if I take the second one and multiply it by 3, do I get 9? You get 18. Right? So, come up with something else.
Number of sides.
What?
Number of sides.
Number of sides where?
Just everywhere.
Just anywhere.
Yeah.
Okay? So you're basically saying the number of lines in the thing, right? So if I start counting 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Looks like she's right? So what's my next one? So how do I develop the pattern? What did I do here? So again, we're looking for a pattern. If you notice here, so you might have to divide the two numbers together. You might have to add or subtract the numbers together. But we have to find some kind of thing. Kenzie's idea was right, counting up the little lines of every single triangle. But how do you figure that out then? So what's the next one? What do you think the next one is? 12? Seems to make sense, right? So if we did the next one, they said 30 segments, and 18 plus 12 is 30 segments. So you're right. And there's my figure. Now, am I going to actually be able to draw that figure? I don't know. Next one, write a conjecture for this one. What are we doing in the denominator? How are we getting those numbers in the denominator? What?
It's B.
It's B. Why?
Because, well, it went 5, 7, 9. So it went by 11 to 36.
5, 7, 9. Oh, okay. Didn't think of it that way. Anybody else come up with some?
Perfect squares.
Perfect squares, right? That's how I got it too. 2 squared, 3 squared, 4 squared, 5 squared, 6 squared would be 36. But the way Keith did it would work too. So he said that it was B. And he is, we don't like to say it, but right. All right, how about this one? So again, we're just thinking. Might have to write stuff down. Make a conjecture about the sum of an odd number and an even number. That lists some examples that support your conjecture. So first off, I just have to be able to understand what the vocabulary means again. So what's the sum? So what's the sum of an odd and an even number all the time? Can you prove it any not being odd? But is 25 and 25 an odd and an even number?
No.
No. So can I ever have an odd and an even number that isn't an odd answer? No, right? So my conjecture would be what? The answer is always odd, and then I would just give some examples. Make sense? How about this one? For points L, M, and N, LM is 20, MN is 6, and LN is 14. Make a conjecture and draw a figure to illustrate your conjecture. So here, this one, they're just kind of throwing stuff out there, right? They don't really tell you anything about L, M, and N. So you got to make up your own figure. Okay? What do you think? What's that? You're going to say M is the midpoint. Why do you say that? Okay, great idea. But then he looked at this one and says that one doesn't have an M. Okay? Anybody else? How about, think about drawing a figure with those things. What figure could I draw? Or shape? A triangle, right? And if I had different lengths of all my sides, what kind of triangle would it be? Could be, maybe. Right? See what they did. So they went and did it a different way. They said that 20 LM was the grand total of the whole thing. And then would LN plus NM equal that 20? So they did it this way. I'm on the same page that you were. The first thing that jumped into my mind was me drawing a triangle. And I would have just had something like this, right? And then I would have said, well, this is the longest side, so that's got to be 20. This is probably the next, so that's 14, and this is 6. Definitely not wrong, right? Either way. Okay? So again, there's going to be a lot of times where you might check your homework with somebody else. They might see things totally different than you. And that's totally okay too. We definitely don't want to be like everyone else all the time. I think that is the last ones that I want you to see. Oh, here. This maybe is the one. Given. So again, as we start working through these processes of getting into proofs, the given is always going to be given to you. And you cannot argue the given. Whatever they say is the given is true fact. Okay? You might not believe in it, and you might not agree with it, but it is true. So they say ACE is a right triangle with AC is being equal to CE. Which figure would illustrate this conjecture?
C.
Why?
I don't know.
You're right, but why? How did you know that it was C?
Because I just looked at the line, but I didn't look at A before that.
So why do you say it could be A?
It can't be done.
Oh,
C.
C's are right.
Right, so the biggest thing here is this statement in the given right here, right? And then if we come over here and look at the little slashes, that's the other key, right? So why can't it be this one right over here, D?
Because C's are right angle.
Because it's not a right triangle, right? How do I know that it's a right triangle? It has to have a box in it. Exactly right. So if it has to have a box, we can automatically eliminate D. This one doesn't have anything that's congruent to each other or equal to each other, so we can throw that out. And then you just have to be exactly sure of which sides. So we would say what? C, right? Perfect. So again, probably nothing that's like mind-blowing today, but you actually have to stop and think. And don't be afraid to draw pictures. Even if your pictures stink, okay? We'll get into some pictures down the line, and they ask you to draw a dolphin. You should see my dolphin. It's not a very good dolphin. But it helps me just so I can look at the picture. All right, questions? There's the assignment. I'll get you those notes before you forget to bring them on.